Yes, sir, we can start.
Okay. Okay. So I think in last class we have gone through some basic commands and most of the notes covers the concepts which you have already learned in your undergrad. But I'll show you one example for the for loop. Okay. So that you'll see how it will help in your DevOps course. Okay. So if you can use the notes under bash conditions loops, you have one for example. I'll just so if you look at the script, the idea of this script is there are small errors. I'll just correct them. Okay. The idea of this script is to read all the .sh files from your home directory or PWD, current working directory, and identify the space it is occupying. Okay. Now, how exactly they are doing this as part of the script? Okay. Look at this line. We are first trying to define the total size and then trying to define the current file as 0. Okay. Then in the for loop, we are reading each file from our current working directory, which is a .sh file, and passing to the for loop. Okay. Now, there are two things you need to know before we go there. Okay. So first let me save it and show you ls minus l. So if you observe ls minus l, this actually returns the permission set, number of links to the file. Okay. I mean, if there are two files inside it, it's a link. Who is the owner, super owner, who is the node owner. And this is what you see is the space occupied by the file in your local machine. Okay. And this is a date timestamp. This is the name of the file. So if you carefully observe, 1, 2, 3, 4, 5. So this is the fifth position. So in the ls minus l command, the fifth position of the command output discusses or presents you the size of the file in bytes. Okay. So what we are trying to achieve with the previous script is to know what is the total size of all sh files which are present in your home directory. What is my home directory? Home and my username folder. Okay. So all these home directory, the current working directory or home directory contains these sh files. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now basically I want to do the sum of the space occupied by all these .sh files in the home directory. Okay. So what I'm doing, I'll go to for files .sh. If you carefully observe in the for loop, this is the place I'm reading all the files. Okay. And look at the command. Okay. Current size equal to, okay. I'm enclosing this command in tick. If you recall from last class, if you want to execute bunch of commands together, you have to mention them under ticks. Okay. Now you have two commands, ls minus l current file. Okay, current file is one file which is being read from this path, and you are trying to squeeze tr-s is to squeeze the spaces. Okay, so the ls minus l output. Let me show you the output. Let me do this. So what is happening in this line is in the ls minus l output for every file. So for every file, we are sending this script, this command output as input to tr-s using pipe delimiter. So this is input output redirection. We are sending the output of ls minus l to the other command as a pipe delimiter. Okay. Then tr-s will actually transform, and hyphen s will squeeze the spaces. Okay. So what are the spaces here? After the command, after the permission set, your space one space username space storage of the file, the size of the file, date timestamp space, and the file name. So it is squeezing those spaces. Okay. Then that output is sent to cut command. Okay. Cut command, and we are cutting at fifth position, hyphen F5. Okay. So what is why it is fifth position? This is position 1, which is permission set. Linkage file, this is second position. Third, owner. Fourth, the group owner. And the fifth, which is the space. Okay. So you are trying to read the fifth position of the squeezed output of ls minus l for every sh file. Okay. So this loop will run for this line. It will squeeze and pick 239 from the this line, and in the second iteration of the loop, it will go to cal underscore sh. It will squeeze the spaces, go to fifth position, and takes 192. Okay. In that way, it takes 239, 192, 163, 527, 527, 56, 36, 63, etc. and does the sum. Okay. So it does total sum plus current size. So every iteration, it's like 0 plus 239, 239 plus 192, 239, 192 plus 163. So that loops runs and then it prints the output. Okay. So that's the example of the script. You can have a look at this by practicing, by copying from the documentation. Let's try to execute this now. Okay. So change mod plus x for files dot sh backslash for files dot sh. So 2784, 2874 is the sum. So it's basically summing 239, 192, 163, 527, 527, 56, all these things. Okay. So that's the way how loops can be used to perform operations on files. Okay. So there are many such examples in the documentation. You can go through them. There are different variants of loops. Okay, for loop, for example, you can loop on range. Okay, from 0 to 1, 2, 3, 4, 5, and then print the value. You can loop on the files, like how you have done the loop on files here in the path. Similarly, you can loop on the files. You can send the current working directory. The pwd is a current working directory, right? So if you do echo $pwd, it will give you the current working directory. So basically, it stores the current working directory in this place, and it eventually returns the output. Okay. Then this is another form of defining the range. Okay, so if you look at this, nano for one.sh. So it is considering one double dot 5 as range, and it reads from starting index to the ending index and prints the output. Okay. This is how typically this for loop works. And there's one more interesting for loop which works with the range and the space. So for example, nano for 2.sh. Yes. Change mod plus x for 2.sh backslash for 2.sh. Look at this. So basically, here in the previous example, you have one double dot 5, which will be like starting index and ending index. But if you look at here, 0 double dot 10 will be the starting and ending index. Dot dot 3 will be the skipping value. Okay. So that's why if you observe, it printed 0 because it's a starting index. It did skip and went to 3 and then to 6, then to 9 and then finished the loop because 10 is the closing index. Okay. So this is one way of writing a loop. And there is another interesting loop where you can do sequence as a command. So I'll show you how that looks like. Look at the sequence SC key 1, 4, 20. Here, 1 is the starting index, 20 is the ending index, 4 is the skipping range. Okay. And this is based on sequence command. Okay. And if you observe, this is enclosed in single brackets and passed by dollar, which is your typical calculation uh, function. Like you can do calculations using let command, expr, double parenthesis, dollar single parenthesis, and basic calculator, right? Similarly, you can do brackets like this and pass the sequence command to the for loop. And when you do that, it actually tries to print you the range from 1 to 20 by skipping 4 values between them. Okay. The last loop is something which you already know. You might have seen in your C, C++, Java, your conventional initialization, range, and increment. Okay, 3 stages of a loop can be implemented. So these are variants of for loop which you can see. Similarly, you have a while loop, which is a standard syntax, which you can just try it at your end. And there is break and continue. Do you know what is break and continue? Anybody? Do you have any idea of break and continue? You should have some idea of break and continue if you're already aware of Java or C.
So break will break the current loop and continue will continue the current loop.
Correct. So basically, you can kick off the loop when the condition, when the judgment condition is not happening, and if you want to continue despite the judgment condition is not happening, then you can have a continue. Okay. So similarly, there are many such examples, and there's a last example which I want to show is the case statement, which is very unique in case of bash. Carefully observe this. So case is written like this. Okay, I'll show you a very neat example over here. So if you go to some examples in the documentation, there is a calculator program. Okay, look at this. So you can use this calculator program. So if you look at this script versus the output, okay. So we are resetting the screen using a clear function and then running a while loop. Okay, it's basically printing what you see on the screen. Now this is the line of execution where it's reading through choice. Case statement is different from typical looping statements because in case of looping statements, you judge a condition in an iteration. Okay, but in case of case, you will use case to judge multiple conditions with an input choice. Okay, for example, now if I give 1, the choice will go to 1 and eventually being judged. Okay, then if it is 2, it goes and it gets judged at a respective case. So whenever you want to do iterative condition judgment, you have to use loops. When you want to do single input multiple judgments, you have to use case. Okay. So look at the, for example, if I do 1, okay, and it asking me to enter non-negative number. So it entered the case. So 1 went here, and from there it went here. If it is matching, then it is throwing this print statement. So I'll give 23 and 45. And then it is reading the input. It is checking whether they're not equal to 0 and not equal to 4. If they're not more than 4 characters, then if the choice is not equal to 4, what is 4? 4 is division. Okay. Then it is actually checking cannot divide by 0, because if the number 2 is 0, it will get divi- uh, divi- what we see, the error, right? The negative integer, it will go to infinity. So it's basically trying to do the basic condition check. Is it second number is 0, not equal to 0, or is it not equal to division, so that it can avoid cannot be divided by 0 error, and it's doing the sum. Okay. So basically, for multiple condition judgment, you can eventually use the case statement. Okay. So I will share the assignment mostly this week. Last week I couldn't do it because I didn't have all your Git IDs. I will create one GitHub Classroom and share you some basic shell questions, okay, so that you can practice and submit your assignment. That assignment is like a exercise where you can do things by yourself and get acquaintance with shell. Some questions are focused toward DevOps, typically file operations, reading data from files, copying from one file to another file. Those type of questions you will end up having. So try to practice them. Once I get the entire list of GitHub IDs, I will announce the assignment. Okay. So this is all with simple bash. All the examples are already available in your notes. Okay. Please go through them. Try to learn them. They will help. They'll be helpful for your mid exam. Okay. Great. Any questions before we begin to the next agenda of the topic, which will be software engineering teams? Yes, no? Okay. Okay. So the notes for today's and tomorrow's session are already available in the Git book. Okay. All the metrics, all the approaches, but I'll try to explain them in a very detailed way so that you all can understand. Are you able to see my screen?
Yes, sir.
Okay. So, today's session is typically on software engineering teams. Okay. So, if you join any organization, a typical organization, let's take an example here, like let's take Flipkart. Okay. FLIP, Flipkart. Okay. What does Flipkart do?
It
Can you
connects
unmute
buyer
yourself?
and seller.
Yeah. So they typically in e-commerce site. So you have a typical buyer, you have a typical seller, and you have the stock, product portfolio, etc., etc. Right? This is a typical gamut of this company. Right? Now, if you dissect their company, they have different teams. Okay. There are product team. Okay. There are developer teams. There are teams who take care of release. Within development team, you will have QA team. There is an R&D team. Okay. There's a sales team, and within that sales teams, you have accounting team. Okay. Now, why do we have such a different dissection when you operate a product like this? Is something key to understand. Okay. These things play a very crucial role to deliver your product to end users. Okay. Now we'll look at how these teams actually pan out. Okay. So imagine if you take a Flipkart as an example, right? Okay. So so for us, Flipkart is an e-commerce site. But for Flipkart, there could be different teams. There could be team which takes care of a typical UI. There's a team which takes care of web. Okay. There's a team which takes care of databases. Okay. There are teams which take care of dev plus R&D. Okay. Research. And there is a team which take care of mobile apps. Okay. Mobile app of um, uh, Flipkart. Now, if you pan out into the organization, how teams are defined. Okay. So for every team, you have a development manager. You will have some 5 to 6 developers. You have one QA resource or two QA resource. Okay. There will be some engineering director who takes care of two or more dev teams. Hmm. Each dev team will have someone called product manager, okay, who defines the features. He will tell you what to create, what to add in the website, so that the development teams eventually build it using with the developer resources, and eventually they are tested by the QA and they are delivered to the release team. Okay. Now, if you look at the example here, I've shared one example in the documentation. Typically, an engineering head is called a CTO, okay? And there will be a teams where you have a web team, a backend team, a mobile team, and each team has different people at a different level of hierarchy. And there are QA teams who work with them, work with the same team, who have a head of QA. There are a bunch of product managers for each respective team who define features. They roll into a one product head. Okay. And there are a bunch of UI UX designer who roll into design team. And there are delivery scrum master or delivery manager who takes care of delivery. So this is how a typical software engineering team looks like. Okay. Now, what happens when a feature is actually defined or given? Okay, given for a release in a typical product. Okay, let's look at the example of Flipkart itself. Imagine Flipkart wants a feature um, like let's look at login page itself. Okay, what does a login page should contain? A username, an input through a text box, a password through a text box, login button, or exit button. Okay, imagine this is the page they want to build. Okay, now look at how different types of teams are involved just to develop this page. Okay, so there will be a UI UX team who design the screens. Okay, using tools like um, Miro. Okay, and what are those tools? Yeah, Figma. You just need to know these tools, okay? You don't need to learn, but for your understanding. So they design the screen in uh, tools like Miro and Figma, and those screens are typically wireframe diagrams, like mock screens, okay? Now, the UX UI designer will give it to a web team, okay? Web team will develop the web page using technologies like HTML, JavaScript, some forms of JS frameworks, okay? And they implement session management. They do asynchronous and synchronous calls, okay? So they develop this piece, okay? Then there will be a backend team who actually creates a database tables to store user info. So they will create a table which should have certain column name, which should have an ID, which should have a column name, where it should take username and it should take password. Okay, so this is how a typical DB team behaves. Then there will be a QA team who actually does the testing of the design, who actually does the testing of whether the design is matching with the web, is the web matching with the DB. So they create basic unit testings, they do functional testing, they do borderline testing. Okay, so they'll check whether the product manager who defined this feature, they will see what he has written. Is asking to provide email as a user ID, or is it just some random string? What is the rules for password? Did he define any rules? Did the web team follow all possible error handling in throwing the error message in UI? Did the DB team handle the right storage standards? Like for example, if username like only alphanumeric is allowed, but when a user is giving numbers like 1 2 3 4 5 as username, are you storing or are you applying any constraint at DB level? So all these things are typically evaluated by the QA team. Okay. Once these things are evaluated, the QA team will sign off the delivery and the code. Okay. What code do you have? You have your web code, you have your DB code. All these are bundled together and are released to the product. Okay, so this is our typical software team behaves. Okay, so the origin point is the product manager. He defines the feature. The UX UI designers will build the mocks. The web team will build using web pages. The DB team builds the DB part. QA team tests it. Once they sign off, they bundle the code and they release it. Okay, this is our typical engineering team works. Any questions so far?
No, sir.
Okay. Now imagine if you are a if you're a company like Flipkart, okay? The team like product management team, they basically have three types of department. One is market research, okay? Then technical product team. Then you have marketing product team, okay? A marketing research team are the typical product managers. They'll go and check what features are there in our competitors. How are they delivering it? Is it helpful for them or is it not helpful? All those studies are typically done by these people. Okay. Then they share that input with technical product management team. The technical product management team will actually define the features. Okay, they'll tell what are the features our product should have, why they need to have, how soon they need to have. All these things are defined by the technical product managers. Okay, then once the product is built and released, there is a marketing product management team who go out and market the product. So they do ads, they do documentation, they also do adoption studies. Okay, so there are tools like Heap, Pendo, okay, which actually capture the click information. So for example, the Flipkart has introduced login page, but how many people are successfully able to log in? How many people are not able to log in? That info is typically captured using the click data. So they capture the clicks, in the user browser, and this marketing team will look at the adoption rate. Is it increasing or is it decreasing, or are people able to understand the page? And they share this feedback with the other teams. Okay, this is typically how a product management team works. You should be focused on the person called the technical product manager. Okay, so for example, the technical product manager will first define what we call an initiative. Okay, initiative is like a large feature. Under initiative, he creates something called epics. Epics are shorter version of a feature. Then under epics, you have a story. Okay, for example, if you draw parallel to it, login is the larger initiative. Okay, then comes the shorter epics are login through mobile, login through web, open login. So these are the epics which they typically create. Then under, for example, mobile, you will have stories. Okay, you'll have bunch of stories. Like you have story for UI UX, you have story for web, you have story for DB, you have story for QA, and you have story for release. Similar story goes with the rest of the epics. Okay, so the idea is the product manager actually creates an initiative for engineering team and writes stories. Okay, how does a typical story look like? Okay, I'll show you one story as an example. So what you're seeing on your screen is the place where all the engineering teams manage their project. So this is one of the tool like called Jira. Okay, Jira is one form of a tool. I'll show you one sample story. Okay. So tool like Jira where product managers write a story like this. They'll tell you that there is one feature which you need to develop. The feature should accept this as input, in what place, how, then, and if there are any other considerations, they have to implement it. Okay. So the developer will create the task like this. So for designing, he'll have some effort for development story, doing testing, doing code review, automation, etc., etc., and then they will complete the development. Okay. So typically, what happens? Tools like this Jira will facilitate the product managers to write the story. Okay, so that you know that epic can be taken care, and eventually that initiative can be implemented. Okay, so if you go back to what we have seen with this team topology, these product managers here actually define the work for all the engineering teams. So they will ensure that all the work you have been doing should be made productive over time. Okay. So for that, they will use certain techniques. So those techniques are something which we look at today. Okay. Few of those techniques which you might already know is what we call waterfall. Okay. What happens with waterfall is the product manager defines the features. Okay. The features will eventually be uh, authored as requirements. Those requirements are eventually sent to the design team, and then it is coded, and then the QA is done, and then there is release. If you carefully observe each step, the output of each step will become the input of other step. If there is any feedback provided here, that feedback will not go back to this feature step or previous step. It has to be released. Then only the feedback is sent back and this loop is continued. So typically what happens if you have a product where the product manager is trying to use waterfall model, he will ensure that your requirements are well defined, the design is clear, the code is clear, and then the QA is done, and then only they'll do the release. Okay. But if there is a product where you're working where you have constant feedback, where the coding team needs some clarification, when the design team needs some clarification, this waterfall model will not. Okay. So it means that when you don't know what exactly you are building, at that point of time, this waterfall model will not work. It will only work in places where you know what are the requirements that are very clear. You have a clear documentation on the design code, and then only your entire product will be released through waterfall model. Otherwise, there will be typical challenge in releasing the product. So conventionally, I think if you look at in early 1980s to 2000s, waterfall model was widely used. Okay. Then came a new model called Agile. Okay. What Agile does is, Agile will take a large work into small pieces. Okay. Each of this work is divided into small pieces, and these small pieces are delivered as the outputs. Okay. How? Imagine you have a team where you have an engineering manager, you have 5 developers, and you have 2 QA team. Okay. And you have to eventually work on a story. Okay. Like login page. So what Agile tells you is, don't follow this entire process in a step-by-step fashion, but repeat this entire process in a short duration. Okay. What is that short duration? They call the short duration as sprint. Okay. So typically sprint is like 2 weeks. Okay. So all the developers and the QA team who are part of a same team work on one or more stories, okay, for 2 weeks. In that 2 weeks, they will imagine this is week one. So you have week one and this is second week. So what they'll do is in the week one, the developer will start developing. Okay. By the time it reaches week one, the stories which are built by the dev team are sent to the QA team. Okay. QA team tests it. It shares the feedback with the dev team. So by end of the week two, they will release the feature. Okay. So these are small tasks which are broken into 2 weeks of sprint and get the job done. This is a typical agile model. So if you look at the documentation, you'll see how agile looks like. So what they basically do is they actually break the entire work into a sprint of 2 weeks or typically 4 weeks. This is Scrum. We'll go there. Okay. 4 weeks, and they'll actually try to complete the work. Okay. But there are small challenges with the agile also. What is the challenge? The challenge is the product manager has to, because the duration is short, the product manager have to define the requirement very clearly. So on the beginning of the first day of what we call sprint, if the story is not clear, okay, the developer may not be able to build properly and he will be in a confusion. Okay. So to avoid that process, there is a variant. There's a new version of Agile. Okay. That version of Agile is actually called Scrum. Okay. What is Scrum? Scrum is also a week on week work. Okay. But it basically follows some additional processes. Okay. So what are those processes? Processes are grooming, which is the first step, story pointing, then the sprint start for 2 weeks, okay, then release, okay. So this grooming happens way before the sprint. So imagine the sprint is starting on Jan 1 and for 10 days you have 2 weeks. So Jan 10 the sprint is going to end. So the stories which the developer team and the QA team wants to do in this sprint, they will groom couple of weeks ahead. What is grooming? Grooming is the discussion on how to implement the feature. So for example, the product manager wants to do a login page. Okay. So they will get one experienced developer, one QA resource to discuss. How do you want to design the page? Do you want to include username? Shall we accept username as email ID? Shall we take password? For password, do we hide password or shall we open password? Shall we give two buttons, login, exit? What is the color scheming? All these things are typically discussed in the grooming section. Okay. In after grooming session, they will tell how much time they need to do this. So how much time the web guys need, how much time the DB team need, how much time the QA team need, typically in hours. Okay. That piece is typically signed off way before Jan 1st. And when the sprint starts, all those stories are done and are released on Jan 10th. Okay. So this is what the Scrum actually helps you to do. So if you look at this image, the Scrum team, the product manager sits with the team and do the grooming. Okay. So you'll basically plan the sprint, how the sprint should be, how much effort you need, what is the time you need, what tools you need, are there any dependencies with other teams. All those items are discussed and they're brought in the sprint. So in the sprint here it's showing 1 to 4 weeks, but typically a sprint is like 2 weeks. Okay. Now in the 2 weeks they will build and develop the feedback, but in the end of the sprint they will do a review. What review they do? They do typically a retrospection. What retrospection they do? Did we plan well? Was our understanding of the feature correct? Did we release it correctly? Do we have any challenges with the other teams? All that discussion they do after the sprint meeting. Okay. So these sprints are cyclic in nature. So imagine you have 52 weeks in a year. Every 2 weeks you have sprint. So basically like 52 by 2. That would be typically how much? 26. So you'll get 26 sprints in a year, which are cyclic in nature. So if you start with sprint 1 in January, okay, imagine you're in Jan, you're starting with sprint 1. Okay, there are 2 weeks, two sprints, right? Two weeks, which are 4 weeks. So Jan has 4 weeks. So it has two sprints because each sprint is 2 week. Okay. Then you have Feb, you have 4 weeks, which is nothing but two sprints. So sprint 1 and 2, sprint 3 and 4, 5 and 6, 7 and 8, which typically pan out in March and April, so on and so forth. Okay. So if you look at the stories which are brought in sprint 1 and 2 may be groomed in last year sprint 25 and 26. So the stories which they have bought in sprint 3 and 4, they'll groom it during sprint 1 and 2. So the point is, if you are sitting in current sprint, okay, the stories of the next +2 sprints, imagine your current sprint is 9. The stories of 11 and 12 sprints are groomed in sprint 9. Okay. So that is how you know it is cyclic in nature. So that you know sprint 1, 2, 3, 4, 5, 6, the stories of 9 and 10 are groomed way ahead. Okay. This is how typical sprints are groomed. Okay. So this is how typical sprints are groomed. So we have seen waterfall, right? We have seen agile, we have seen scrum, and there's a last approach which is called Kanban. Okay, which is called Kanban. Kanban is a method which will help you do shorter tasks. Okay, like for example, building a feature like login page may take the resources of a web team, a DB team, a QA team, a release team, right? But there are shorter tasks which need to be done in an hour or a day or 2 days. Examples: providing access, login access, deleting a tuple, deleting junk data, okay, changing the text in the UI. All these are very small tasks which you don't need to wait for 2 weeks to build, groom, and then release, right? So these shorter tasks are converted into Kanban board. Okay, Kanban board is a board where you know you have tasks organized like to dos, in progress, review, and done. Okay. Kanban is actually a Japanese word which actually means what is there in the stick note. Okay. So I'll show you how that Kanban looks like. Okay. So this is how a typical Kanban looks like. All the tasks are listed in the requested section. There will be in progress and there will be done. This is a very basic board. You can have another subtask like in progress or under review or feedback. Those things can be defined in the board. So the point is you take a task, you complete that day and close it. You take the task, you move it to in progress, work on it and close it. So these typical tasks are shorter tasks. I'll show you one Kanban board. Okay. This is the Kanban board I use for my data analyst team at my end, in my team. So there's a data intelligence team. So these are the daily tasks which we have. And these are in progress. These are done. So our sprint is typically entire Jan. So for 1 month, we'll write whatever tasks we have. We work on them and we complete them into done. Okay. So all the coding you do, all the development activity you do will come into those tickets or the requests which are there. So these are the potential approaches to organize the engineering work. Okay. So one second, let me add one slide. Hmm. So these are the potential works to organize the engineering task. So to summarize, okay, typical SC team will have an engineering org, a product org, a QA org. Okay, you can refer to the notes for the diagram. So there will be engineering managers and teams. The product team will give requirements. The QA team will do the test, and the release team will release the product. Okay, this is our typical product management team looks like. Typical software engineering team looks like. And there are processes like waterfall, where your processes are like step by step in nature. You do requirements, then you do design, then you do code, then you do QA, and then you do release. And there are other approaches like agile, where you don't need to wait for the entire process to complete, but you do it in a shorter task, so that shorter durations, so that you deliver in pieces and pieces. And then you have another approach called Scrum, which is a variant of Agile, where you organize your work by doing grooming of story. Okay, then you give story points, which is nothing but amount of hours you need to build a feature, and then you define a sprint, and you after the sprint is completed, you do a retrospection, how your sprint went. Do I need to change my story pointing? Do I need to groom better? So that is Scrum. For more smaller tasks, you will end up using what we call Kanban, where it is typically a to-do activity. You have items in progress and done. Okay, these are something given for a daily task. Okay, so this is how software engineering teams are organized. Okay, and this is how they implement their work. So if you join any organization tomorrow, you will find a similar engineering org. Either they will be using waterfall for your team, they might use agile, they might use scrum, they might use kanban, or combination of all based on the task you perform. Okay, so these are the engineering team topologies and the tasks they do. So if you look at the notes, you will find what is scrum in detail, what is Kanban in detail, what is waterfall in detail, what is agile in detail. Do some reading, okay? This will eventually help us in our next class on how people define effort, how to calculate the effort. If I have if I have to release a big e-commerce site with a headcount of 50 people, how soon I can deliver. With a headcount of 100 people, how soon I deliver. With a headcount of 10 people, how soon I deliver. How do we define the effort and cost? What techniques people use? And what is the debt? How to calculate debt? What are the equations for calculating debt? And what is software development waste? How to calculate waste, what are the formulas, all those things we'll look at in the next session. Okay, so in this DevOps course, it is very important for you to understand software teams, because DevOps is developer operations. For a DevOps team, a team for DevOps will operate differently for a Scrum delivery, for Kanban delivery, for Waterfall delivery, and for Agile delivery. Okay. So this class will be foundation for you to understand camps. In camps, you can see how a DevOps team addresses requirements for a Scrum team, for a Kanban team, for a Waterfall and Agile team, how they will compute effort, how they will compute waste, how they will verify the debt. All those items we will go through in our next class. Okay. Any questions so far? So for the people who already worked in industry, I hope few of them have already worked in industry. Can you correlate with these concepts? No. Prasad, what is your question? You can unmute Prasad and ask the question. Oh, no question. Okay, cool. Okay, so let's meet tomorrow and try to look at some formulas for calculating effort, calculating debt, and also calculating waste. Okay, thank you and have a great day. Bye.
Thank you, sir. Bye.